Sample size calculations by Shaheen Shams, Karina Golovay, Oksana Dulugan. Sample size for desired margin of error. To determine sample size n that will yield a confidence interval for a population mean with a specified margin of error m, set the expression for the margin of error to be less than or equal to n, and solve for n. Z star is our expected z-value, theta is our standard deviation, m is the margin of error, n is the population size, what we are looking for. Sample problem 1. A company management wants a report of the means cans of soda production accurate to within 5 plus minus ounces with a 95% confidence interval. How large of a sample of cans of soda must be measured to comply with this request? We know that standard deviation is 43.
Plus or minus 5 cans is our margin of error, which is m. 95% confidence interval is our z-star value, which is approximately 1.96. And standard deviation is 43, which is beta.
Sample problem 1.
We are looking for n. We replace z-star with 1.96, m with 5, and beta with 43. We will take the reciprocal of each side to place n in the numerator and switch the less than sign to a greater than sign. We will then cross multiply the z-star and the standard deviation to place it on the right hand side and isolate n. This is the outcome of that. When we solve that, we get 16.856. Then we square both sides, and we get n is greater than or equal to 284.125. Because n is a whole number, we must round to 285 cans. And our final answer is n is equal to 285 cans.
Sample size for desired margin of error. To determine sample size n that will yield a confidence interval for a population proportion p with a specified margin of error m, set the expression above for the margin of error to be less than or equal to m, and solve for n. 1. Use a guess p-star based on a pilot study or past experience with similar studies. 2. Use p-star equaling 0.5 if all else fails. Sample size for desired margin of error. Z-star is our expected z-value. P-star is a guess value for the sampled proportion. M is the margin of error. N is the population size, what we are looking for.
Sample problem 2. Anna and George are running for class treasurer in a very large school. You are planning to determine what % of students are planning to vote for Anna. This is a population proportion P. You will contact a random sample of students in the class. You want to estimate P with a 95% confidence and margin of error no greater than 3% or 0.03. How large of a sample do you need? The results of these elections usually come between 70% and 30%, so we will use P star is equal to 0.5. P with a 95% is the z-star value, which is approximately 1.96. 0.03 is our margin of error, which is m, and 0.5 is our P star value. And once again, n is what we are looking for. We replace C star with 1.96, M with 0.03, and P star with 0.5. Then we multiply each side with the square root of n and divide it by 0.03 to isolate n, and we solve the top. We get 32.667 is less than or equal to n, then we square both sides and get 1067.1 is less than or equal to n. We will round to 1068 because you cannot have a fraction of a person vote.
Closing. In practice, taking observations costs time and money. The required sample size may be impossibly expensive. Do notice once again that it is the size of the sample that determines the margin of error. Population generally does not influence the sample size we need.